What's up, everybody? In this video, I'm going to teach you everything you need to know to start coding with Python. I've also included 20 different hands-on projects to help you learn. You can find the entire list in the description of this video. Our final project will be a weather app that fetches real-time weather data from an API. Even if you've never coded anything in your life before, I'll walk you through the basics, the ABCs of programming. If that sounds good to you, then I encourage you to sit back, relax, and enjoy the show. This course doesn't cost you anything, but if you would like to help me out, you can help increase its reach by hitting the like button, leave a random comment down below, and subscribe if you'd like to be a fellow bro. Thank you, I appreciate it. I don't like boring introductions, so I say we just jump right in. There's two things we'll need to download. The first is a Python interpreter to convert our written code to machine code. We're going to head to python.org, go to Downloads, and download the latest version. We will open this executable. If you're on Windows, you'll want to check this checkbox, Add Python exe to path, and we will install now. The setup was successful, and that's all you need to do to download the Python interpreter. The second download we'll need is an IDE, an integrated development environment, basically a place where we can write code. For IDEs, there's two popular choices when writing Python code, PyCharm and VS Code. If you already use VS Code, you can stick with that, just be sure to download the Python extension. I find PyCharm more beginner-friendly if you've never coded before. If you would like to use PyCharm, go to jetbrains.com/PyCharm, and we will click this green download button. There's two versions of PyCharm, the professional version and the community version. The professional version is paid for. I would not recommend using it, only because there's plenty of free IDEs on the market. We'll use the community edition, the free one, because I don't like to pay for things, and I'm sure you don't either. Select the correct download for your operating system. I'm running Windows. I will download PyCharm. We will open this executable, click Next. You could select a destination folder. I'll keep it as is. Next. I'll create a desktop shortcut, but you don't necessarily need to. Click Next, Install, and we'll just have to give it a moment. Okay, the setup is now complete. I'll check this checkbox to run PyCharm when we close this window. After opening PyCharm, we're going to create a new project. You can rename your Python project. I'll keep it as is. You can select a location. Again, I won't change that. You can create a sample welcome script, but for this tutorial, we won't. Let's select the latest Python version and create our new project. In the menu to the left, we're going to create a new Python file. File, New, Python file. Let's name this file main. But really, you can name it anything. And select Python file. Python files end with the py file extension. We should have our main Python file within our Python project folder. Now we're going to print something to the console window. Within our main Python file, we're going to write a print statement. So type print, add a set of parentheses. Between the set of parentheses, we will add a set of double quotes to print something, or single quotes, either one. My own preference is double quotes. Normally in a programming tutorial, the instructor would tell you to print something such as hello world, but we like to be different here. Instead, think of your favorite food. In this case, I like pizza. I will print I like pizza. To run our Python program, we will click this green arrow to run our main Python file. We should have a console window that displays our output, I like pizza, or whatever your favorite food is. Let's print another line of code. Let's print, it's really Good. By adding a second print statement, we are printing a second line of code. Now we'll discuss comments. The Python interpreter doesn't output comments. To write a comment, you use a £. I like to call this a hashtag. My comment will be, "This is my first Python program." Comments are used as notes for yourself or for other people reading this code. If I were to run this code again, this comment is not displayed to the output. We still have, "I like pizza, it's really good." Alright everybody, so that is your very first Python program. And in the next topic, we'll discuss variables. Alright everybody, we are moving on to variables. A variable is a container for a value. There's 4 different data types we'll discuss: strings, integers, floats, and booleans. Yes, I know, that's a silly name. A variable behaves as if it was the value it contains. Each variable should have a unique name. Let's say we have a variable of first name. To assign a variable, you use the assignment operator of equals. For text, a string is a series of text. This can be double quotes or single quotes. My own preference is double quotes. Why don't you type in your first name? This variable, a first name, will behave as if it was this value, this series of characters. So to demonstrate this, I'm going to print my first name variable. So place it within a print statement without quotes. That will print your first name. Now you don't want this within quotes, because then you're literally printing the word first name. You could use your variable along with some text by using what is called an f string. That's the easiest way to display a variable. So you type f, then a set of quotes. The f means format. So let's say the word hello, then we will add our variable. We will insert our variable into this text when using an f string. To do that, you need a set of curly braces, then insert your variable. So the result is hello, whatever your first name is. In my case, bro. Let's create another variable. Let's say we have a variable of food. Food equals, think of your favorite food. For me, I will type pizza. Let's print the following. You like, add a placeholder. Again, I'm using an f string. Our variable of food. Hello, bro. You like pizza. Let's create an email. Use your own email or make up one. Let's say my email is bro123@fake.com. Then let's print our email. Your email is, add a placeholder, display our email variable. Your email is bro123@fake.com. So these are strings. I'm going to add a comment that these are strings. A string is a series of characters. They can include numbers, but we treat them as characters. Now we have integers. An integer is a whole number. An example of this could be somebody's age. How old are they? According to my YouTube statistics, many of you are between the ages of 18 through 24. Let's say that I'm 25. Let me zoom in a little. Your integer should not be within quotes, because it would be a string then, technically. If I would like to work with this variable, again, I'll use an f string. Let's say you are, add a placeholder, display our age variable, years old. You are 25 years old. Another example of an integer could be a quantity. You are buying a certain amount of something. Maybe I am buying 3 items. I wouldn't have half an item. This would be a float, technically, rather than an integer. We are buying 3 of something. So let's print the following. You are buying, add a placeholder, display our quantity, items. You are 25 years old. You are buying 3 items. Another example of an integer could be an amount of people. Let's say num of students, like a classroom. There are 30 students in our class. Then we will print your class has, add a placeholder, students. We will display the number of students, num of students. Your class has 30 students. Those are integers, they're whole numbers. And again, make sure they're not within quotes, because then technically they would be a string. Integers we can use in arithmetic expressions. If they were strings, we couldn't. Then we have floats. Float means floating point number. A float is a number, but it contains a decimal portion. An example would be a price. What is the price of something? $10.99. Let's print our price. Print, I'll use an F string. The price is, add a placeholder, display our price. The price is $10.99. Let's precede our placeholder with a unit of currency. I'll pick American dollars, but feel free to pick something else. The price is $10.99. So floats contain a decimal portion. What about a grade point average, GPA? Let's say my GPA is 3.2. Then I will print your GPA is, display our GPA. Your GPA is 3.2. What about a distance? A distance can contain a decimal portion. 5.5 kilometers, maybe. Then I will print you ran, add a placeholder, display our distance, then I'll add km for kilometers. Or you could add mi for miles, but I'll stick with kilometers. You ran 5.5 kilometers. Okay, then we have booleans. A boolean is either true or false. Let's say we're a student. Is student equals, if we are a student, we could say that this is true. True starts with a capital T. If we weren't a student, let's say we graduate, we could say that this is false. Again, the first letter is capital. Booleans only have two options, true or false. So let's say that I am a student. Then I will print, are you a student? Then we will display our Boolean value of isStudent. Are you a student? That is true. With Boolean values, we really don't output them directly. You're more likely to see them used internally within a program, such as when working with if statements. This is a topic we'll discuss in the future, so don't worry. You may see if is student, if this variable is true, then we will print the following. Now, we don't need to use an F string. We're not going to insert any variables. You are a student. If this were false, we can add an else clause, where we will print, you are not a student. Our variable of isStudent is true. We will print the if statement. You are a student. If this were false, we will print whatever's within else. You are not a student. Let's think of a few more examples. Is something for sale? Like a car or a product of some sort. Let's say that is true. I'll write another if statement. If for sale, if this variable contains true, we will do the following. Let's print that item is for sale. Else, if it's false, we will print something else. That item is not available. For sale is set to true. This variable is true. We will print that item is for sale. Else, if it were false, we print that item is not available. One more example. Let's say we have a Boolean variable of is online. Is somebody online? I will set that to true. If is online, if that's true, we will print you are online. Else we will print you are offline. Is online is set to true. We will print you are online. Else if it were false, we print you're offline. Alright everybody, so those are variables. A variable is a reusable container for a value. There's 4 basic data types for beginners. A string, which is a series of text. Integers, which are whole numbers. Floats, which are numbers, but they contain a decimal portion. And booleans, which are either true or false. They're binary. Your assignment in the comments section is to post 4 variables. Post a string, an integer, a float, and a boolean. Try and think of a unique example if you can. And well everybody, those are variables in Python. Alright everybody, so we are moving on to typecasting. Typecasting is the process of converting a variable from one data type to another. We have various functions to convert a value or variable to a string, an integer, a float, or a boolean. Let's create some variables. We will create a name variable. Type in your full name. An age, make up some age. A GPA for grade point average, let's say minus 3.2. And a boolean of is student. Are we currently a student? Let's say that's true. Now, you actually could get the data type of a variable or a value by using the type function. Then pass in a value or variable. However, when I run this, there's no output. So I need a print statement. We will print what is returned by the type function. Get the type of our name variable, then print it. So our name variable is a string, str. Our age variable is an integer, an int. GPA is a float. Is student is a boolean. Using these typecast functions, we can convert from one data type to another. Here's how. Let's start with something simple. Let's convert our GPA to an integer. Currently it's a float. I will reassign GPA, use the int function to typecast to an integer, then pass in my GPA. At the end, we will print our GPA. If we typecast 3.2 to a whole integer, what would the result be? A whole integer of 3. We truncate the decimal portion. Let's convert our age to a floating point number. We will reassign our variable of age, use the typecast function of float, then insert our age variable. Let's print our age variable, and it should be a floating point number, 25.0. Now we'll cover strings. Let's typecast our age to be a string. Age equals, call the typecast function of string, str, pass in our age variable. So the result is still going to appear the same, 25. However, it's a string, not an integer. And to prove that, I will enclose my age variable with the type function. The type of variable age is a string. It would be the same as if we're taking this number and enclosing it within quotes. So this would make a difference because let's say that I add 1 to age. Age plus equals 1. Well, we would get a type error. Can only concatenate strings, not integers, to a string. However, if I were to add a string of 1 to the end, we would be using string concatenation. So let's say it's my birthday, and I add 1 to 25. Well, since we're working with strings now, the result would be 251. I am 251 years old. So, strings and numbers behave differently. With numbers, we can use them within arithmetic expressions. Strings, not so much. We will take our name variable and typecast it to a boolean. Name equals call the typecast function of bool, pass in our name variable. This has an interesting result. So I'm going to print name. Booleans are either true or false. If I typecast my string of text into a Boolean, that gives me true. Now it really doesn't matter what I write here. If I were to change my name to a single character such as B, this would still be true. If our string variable was empty, there were no characters within it, that would actually give us false. We could use this to check to see if somebody enters in their name or not. If somebody types in their name, then we typecast it to a Boolean. If somebody skips entering in their name, that would return false. We could reprompt the user to enter in their name again. Alright everybody, so that is typecasting. It is the process of converting a variable from one data type to another. This is especially useful with handling user input, because user input is always a string. There may be at times where you want to convert it to an integer, a float, or a Boolean. And well everybody, that is typecasting in Python. Alright everybody, in this topic I'm going to show you how we can accept user input in Python. We use the input function. It's a function that prompts the user to enter in data, and it returns the entered data as a string. Here's an example. To accept user input, we will call the input function. When I run this program, we need to enter in data to our console window, like so, then hit enter. However, we need a prompt. We need to tell the user what we want them to type in. So let's ask a question. Our prompt will be within quotes. Let's say, what is your name? Let's try this again. What is your name? I can type in something. Why don't you go ahead and type in your full name? Then hit enter. Now with this input, we're not quite doing anything with it. The input function is going to return some data as a string. We can assign it to a variable if we would like. Let's create a variable of name. Name equals our user input. Then once we have our name, let's print a message. I'll use an F string. We will print hello, add a placeholder, then insert our name variable within that placeholder. Let's try this. What is your name? Type in your name, hit enter, hello, whatever your name is. Let's try a different name. I will pick SpongeBob. Many people are familiar with SpongeBob. Hello, SpongeBob. This time, we will ask a user how old they are. Let's assign a variable of age equals accept some user input. We need a prompt within quotes. How old are you? Once we have our age variable, let's print, I'll use an F string, you are, add a placeholder, our variable age, years old. What is your name? Type in your name. How old are you? Let's say that I'm 25. Hello, whatever your name is. You are, whatever your age is, years old. Alright, so let's say that it's our birthday. Before we print our age variable, let's say, happy birthday. Since I'm not inserting any variables within this print statement, this doesn't need to be an F string. You'll want to use an F string if you want to insert variables. Before we display the user's age, let's take the user's age and increase it by 1. We could say age equals age plus 1. But there's one problem with this. Type in a name. How old are you? Type in an age. And we have a problem. We have a type error. Can only concatenate strings, not integers, to strings. When we accept user input, we store that input as a string. Before we increment our age by 1, we'll need to convert it to an integer. We can't normally use strings within arithmetic expressions, but we can do that with integers and floats though. After we accept some user input for our age variable, we could take our age variable and typecast it as an integer, which we talked about in the previous lesson. So let's say age equals our age after we typecast it, then increment it by 1. So type in your name, type in an age, and we get this message. Hello, your name, happy birthday, you are, whatever your age is, years old. So strings we can't normally use with arithmetic expressions. We would have to typecast it to an integer or a float. However, we could condense some of these steps. We're taking up an extra line to typecast our age as an integer. What we could do instead is that when we accept our user input, we can enclose the input function within a typecast to int, and that would work the same. Type in your name, type in an age, and this works the same. And it takes less lines of code, and is more readable, I would say. When we accept user input, it returns that input as a string data type. Then we just have to typecast it to another data type if we need to, and in this case for age, we do. Now we'll go over a couple exercises, because it's important to practice what you've learned. In this first exercise, we're going to calculate the area of a rectangle. We need to prompt the user to enter in a length and the width of a rectangle. So we will create a variable of length. We will accept some user input using the input function. What is our prompt? Let's say enter the length. Let's do this with width. I'll just copy and paste what we have. Width equals enter the width. So we have the length and the width. To get the area of a rectangle, we have to multiply the length by the width. So let's say area equals our length variable. Now to use multiplication, you use an asterisk. We'll discuss different arithmetic operators in the next lesson. So we have length times width. That is the area. I'm going to print our area because I need to test something. Enter the length, let's say 5 inches, 5 centimeters, doesn't matter. Enter the width, 6. We get a type error, can't multiply sequence by non-int, non-integer of type string. When we accept user input, it returns a value of the string data type. We can't use those strings in arithmetic expressions. We're multiplying the length times the width. We would need to typecast them as an integer or a float. Since we're working with basic geometry, such as calculating the area, let's do float. So let's typecast our user input as a float for both length and width. Okay, let's try this again. Let's say 5 times 6. The area that's returned to us is 30.0. This result contains a decimal. It's a floating point number, a float. So when we print the area, I'll use an F string this time. The area is, I'll add a placeholder, display our area variable. Let's add a unit of measurement afterwards. I'll pick centimeters. Now, since we're working with areas, if we would like to technically be accurate, so we could say to the power of 2, or we could add a superscript. So if you would like superscript 2 and you're on Windows, make sure numlock is on, hold Alt, then type on the numpad 0178. So we have a superscript of 2. Again, it's not really necessary for this lesson. I just think it'd be cool to include it, because then it's technically accurate. Alright, let's say that the length is 6.1, and the width is 7.2. The area is 43.92 centimeters squared, because we're working with areas. Let's cover a second exercise. This time, we will create a shopping cart program. Exercise 2. We're going to create a shopping cart program. We need 3 variables, an item, a price, and a quantity of those items. We will create a variable of item. We will accept some user input. What item would you like to buy? What are we trying to purchase? We'll keep the data type of the user input as a string. Then we need a price. What is the price of each item we're buying? Use the input function. What is the price? A price should be a floating point number. For example, we might have dollars and cents. We need a decimal. So let's typecast our input as a float. Then a quantity. We will accept some user input. Our prompt will be, how many would you like? Quantities, they should be whole numbers. Let's typecast our input as an integer. Then we will have a total. What's the total that we have to pay? So let's take the price of each item, use an asterisk for multiply, our quantity. Then let's do a test run. Let's print our total. What item would you like to buy? Let's say a pizza. What is the price? $10.99. How many would you like? I would like 5 pizzas. And our total is 54.95. Let's say that before we display the total, let's print the following. I'll use an F string. You have bought, insert a placeholder, display our quantity, X, item, or items, I'll add /s. Then we will print, I'll use an F string again, your total is, display our total. What item would you like to buy? I would like to buy a pizza. What is the price? $10.99. How many would you like? I would like 9 pizzas. They're all for me. I'm gonna eat all of them. You have bought 9x pizzas. Your total is 98.91. Let's add a unit of currency before this. Pick unit of currency before displaying the total. I'll pick American dollars. I would like to buy pizza. What is the price? $9.99. How many would you like? I would like a dozen pizzas. 12. You have bought 12x pizzas. Your total is $119.88. Alright everybody, that is how to accept user input in Python, and we've covered a few exercises. In the next topic, we're going to create a Mad Libs game, and that is how to accept user input in Python. Alright everybody, in this video we're going to create a game of Mad Libs. Not because we have to, but because I want to. It would be a good exercise for us, just so we're more comfortable with accepting user input. If you're not familiar with Mad Libs is a word game where you create a story by filling in the blanks with random words. So we're going to create a story template. The story is going to be missing some components. We will fill in those components with random words that we type in. Here's a story that I've written myself. Print, use an F string. Today I went to a, insert a placeholder, zoo. For our placeholder, we'll insert an adjective. We'll insert a variable named adjective. Adjective 1. You're going to get an English lesson today too. An adjective is a description of something. So for our zoo, adjective 1 could be expensive, large, dirty. An adjective describes something. We'll fill this in when we accept user input. For our second print statement, let's print the following. In an exhibit, I saw a placeholder. We'll include a noun. Noun 1. A noun is a person, place, or thing in English. Maybe a gorilla. A gorilla named Harambe, for example. Print, use an F string. Let's say our noun 1, whatever this is, we can reuse variables, was, we will create a second adjective, adjective 2. We will be describing whatever noun 1 is, this person, place, or thing. And we will insert a verb, verb 1. A verb is an action, such as running or eating. Then for our last statement, let's print I was, add a placeholder. We'll create adjective 3. Adjective 3 will describe us. Now we're going to fill in these variables by accepting user input. We're going to fill in adjective 1. We'll accept user input using the input function. Enter an adjective. I'm going to add a reminder that an adjective is a description of something. Then we need noun 1. Noun 1 equals input. Enter a noun. A noun is a person, place, or thing. Then we have adjective 2. I'll just copy adjective 1, paste it, change 1 to 2. Then a verb. Verb 1 equals input. Enter a verb. I want verb 1 to be in current tense. I'll ask the user to end the verb with ing. Enter a verb ending with ing. Then it's current tense. Our person, place, or thing of noun 1 is currently doing something, such as eating. And then adjective 3, and I'll just copy one of these adjectives. Adjective 3 equals input, enter an adjective. Okay, and then we are ready to run this. Enter an adjective. An adjective describes something. I will say suspicious. Or some kids like to say sussy, or sus even. I've also heard of kids nowadays using the word skibbity. Feel free to type in whatever you would like. It is your story, after all. I'm gonna say suspicious. Enter a noun, a person, place, or thing. I like to poke fun at Mark Zuckerberg, so I'm gonna say my person is Mark Zuckerberg. Enter an adjective. That is a description. Angry. Enter a verb ending with ing, so it's current tense. Screeching. Enter an adjective. Happy. Here's my story. Today I went to a suspicious zoo. In an exhibit, I saw a Mark Zuckerberg. Mark Zuckerberg was angry and screeching. I was happy. That's our game of Mad Libs. It's a word game where you create a story by filling in the blanks with random words. Also, post the output of your Mad Libs game in the comments section down below because I really want to read them. I want to see what you guys came up with. And well, everybody, that is a Mad Libs game using Python. Hey everybody, in this video I'm going to show you all of the different math that we'll need throughout the rest of the series. I have a lot to cover, and I'll split this video into different sections. We'll cover some basic arithmetic operators, built-in math functions, a few functions from the math module, and then a few exercises. Be sure to look at the timestamps if you would like to skip ahead to another section. Let's begin with some really easy stuff. We're going to cover some basic arithmetic operators. Let's say we have a variable, friends. Currently, you have 0 friends. If you need to increment a variable by 1, you could say friends, the name of the variable, equals the name of the variable again, plus 1. So the plus sign is the addition operator, and I think we do have a little bit of experience with that already. So if I were to print my variable friends, guess what? You now have 1 friend. We could also shorten this line of code. You could say friends plus equals 1. That would do the same thing. This is known as an augmented assignment operator. That will give you the same result. I prefer to use augmented assignment operators just because they take less text, and I think they're easier to read. Now let's use subtraction. Friends equals friends minus 2. So, of course, minus is the subtraction operator. You have negative 2 friends, I guess. If you were to use the augmented assignment operator, that would be friends minus equals 2. There, you still have negative 2 friends. Okay, multiplication. Let's change friends to, how about 5? Friends equals friends times 3. You now have 15 friends. Then the augmented assignment operator version of this would be friends times equals 3. So, again, you have 15 friends. Let's cover division. Friends equals friends divided by 2. So we have 2.5 friends. Somebody was cut in half. We have half a friend. Maybe it's just their legs or torso or something. Then the augmented assignment operator would be friends divided by equals 2. And the result is still the same. Now exponents. Friends equals friends to the power of 2. So friends is currently 5. Friends to the power of 2 would be 5 times 5, which is 25. The augmented assignment operator version of this equation would be friends exponent equals 2. And again, friends is 25. Then we have modulus. Modulus gives you the remainder of any division. Suppose we have 10 friends instead of 5. I will assign a new variable, remainder. Remainder equals friends. The percent sign is known as the modulus operator. It will give us the remainder of any division. If I were to divide my group of friends by 3, we will have 1 remaining. I'll store the remainder within a separate variable. We would have a remainder of 1. It's kind of like in class when the teacher says for everybody in the class to go into groups of 3. Then there's always that one kid that's by themselves. That's kind of the same concept. We're dividing our friends into groups of 3. Then the modulus will give you the remainder. If we divided our group of friends into groups of 2, well, 10 divides by 2 evenly, so there is no remainder. So that is the modulus operator. It's fairly popular to use this operator to find if a number is even or odd, because it will divide by 2 evenly if that number is even. If the remainder is 1, that means that the original number is odd. Okay, so yeah, those are some basic arithmetic operators. Addition, subtraction, multiplication, division, exponentiation, then modulus. Now what we're going to do is cover some built-in math-related functions. Suppose we have 3 variables, x equals 3.14, y equals 4, z equals 5. It doesn't matter if these are floating point numbers or whole integers. The first is the round function. We have a variable named result. I'm going to round x. So there is a built-in round function. After the set of parentheses, we can add some value or variable to be rounded. So we will round x to the nearest whole integer, then print the result. So our result is 3. So that's the round function. With the absolute value function, we can find the absolute value of a number. Let's change y to be -4 instead of 4. We'll take result equals ABS, which means absolute value of y. The absolute value is the distance away from 0 as a whole number. The absolute value of -4 is 4. Okay, let's change y back to 4. There's a built-in power function. Result equals pow. Then we'll need a base and an exponent. What's y to the power of 3? That would be 4 times 4 times 4, which is 64. That's the pow function. You can raise a base to a given power. The next two are really useful. Using the max function, we can find the maximum value of various values. What's the maximum value between x, y, and z? Then I'll just need to store this value. Result equals the max between x, y, and z. Well, the maximum value is 5. Otherwise, there's min. What's the minimum value between x, y, and z? That would be 3.14. Now, in this next section, we do have some very useful constants and functions from the math class, but we'll need to import the math module at the top of our text editor. So import math. If you need the value of pi, you'll type the name of the math module, .pi. And I'm just going to print this. Print math math.pi. The value of pi is 3.14159 and a bunch of digits that come after. If you're working with physics, I do know that people use the constant e a lot. We won't be using e in this video series, but if you ever need access to it, just type math.e, and that will give you e, which is 2.71 something something something. I believe e is known as the exponential constant. If you need the square root of a number, let's say result equals math.sqrt, we can place a variable or a value within the square root function. Let's say we have x again. X equals 9. What is the square root of x? Then I will print whatever the result is. The square root of 9 is 3. That is the square root function. There's a ceiling function. Result equals math.ceil. Ceil will always round a floating point number up. Suppose x is 9.1. So 9.1 rounded up is 10. Otherwise, there's floor, which will always round a number down. Result equals math.floor. Let's change x to 9.9. 9.9 rounded down is 9. Those are some useful math functions. Let's go over some exercises. Okay, in this first exercise, we are going to calculate the circumference of a circle. We'll need the help of the math module, because there's some good functions in there. To calculate the circumference of a circle, the formula is 2 times pi times r. Let's ask a user for a radius, because that's what r is. We'll accept some user input. Enter the radius of a circle. We will typecast the input as a floating point number. To calculate the circumference, again, the equation is 2 times pi, we can get that from the math module, times whatever the radius is. And the user is going to type that in. Then we will print whatever the circumference is. Print, we'll use an f string. The circumference is our variable circumference. Enter the radius of a circle. I'll enter 10. Actually, 10.5. Their circumference is 65.97. If you want to round and truncate some of these numbers, we can use the round function around circumference, then round to a given decimal place. I'll round to 2 digits. Again, 10.5 rounded is 65.97. You could add a unit of measurement too. Let's say centimeters. 10.5 is 65.97 centimeters. All right, that is the first exercise. For this next exercise, let's calculate the area of a circle. We'll import the math module. We'll ask for a radius, much like before. Radius equals input. Enter the radius of a circle. We'll cast our input as a floating point number. The equation for the area of a circle is pi times radius squared. We could easily use the built-in power function to raise our radius to the power of 2. Then we will display the area. Print, I'm using an f string, the area of the circle is our area to some unit of measurement, let's say centimeters, squared. Enter the radius of a circle, 10.5. The area of the circle is 346.36, but I would like to round this number to 2 decimal places. I'll use that round function, and I'll place area and the number of digits to round to within this function. Let's try that again. 10.5. The area of the circle is 346.36 centimeters squared. That is the second exercise. For this last program, we're going to find the hypotenuse of a right triangle. The formula to calculate the hypotenuse of a right-angled triangle is c equals the square root of a squared plus b squared. We'll begin by importing the math module. We'll ask the user for the lengths of side A and B. A equals input, enter side A. We'll cast the input as a floating point number. We'll do the same thing with side B. B equals enter side B. Now this part's going to be confusing. We'll calculate C. We'll need a squared plus b squared. We'll take a to the power of 2 plus b to the power of 2. Then we'll need the square root of all of this, whatever the result is. I will surround this equation with math.square root. And that should give us our answer. Let's print, using an F string, side C equals whatever C is. So enter side A, 3, side B will be 4, side C is 5. All right, everybody, so that was everything related to some arithmetic operators and math-related functions in Python. And in the next video, we're going to cover a few things involving string formatting. Hey everybody, in this topic I'm going to explain if statements. An if statement is used to do some code only if some condition we set is true. Else, we could do something else. It's a basic form of decision making. If it's true, we do something. If it's not true, we don't do it. Let's ask a user for their age. Age equals input, enter your age. I will typecast the input as an integer. Depending on what the user's age is, we can do one of a few things. Let's pretend that the user would like to sign up for a credit card, but in order to do so, their age needs to be greater than or equal to 18. Well, we can check that. To use an if statement, type if, then some condition. What would we like to check? Let's check to see if the user's age is greater than or equal to 18. Then add a colon, then hit enter. Any code underneath the if statement should be indented. Make sure to pay attention to that because that's easy to miss. If the user's age is greater than or equal to 18, let's print, you are now signed up. If I were to run this code, I'll type in my age, I'll type 21, hit enter. This statement is true, therefore we will execute any code found within the if statement. You are now signed up. What if this condition was not true? Let's say my age is 13. Well, nothing happens. If the condition we check is instead false, we skip over this code. If you need to take a different course of action, you could add an else statement. If this is true, do this. Else, we can do something else. Let's print a different message. You must be 18 plus to sign up. I'll type in my age again. I'll say that I'm 13, hit enter. You must be 18 plus to sign up. That's basically an if statement. Do some code only if some condition is true. Else, you can do something else entirely. It's a basic form of decision making. The else statement is kind of like a last resort. We can check more than one condition before reaching the else statement. We can add an else if statement, which we just shortened to ELIF, meaning else if. Else if, let's check if age is less than 0. Then we'll print a different message. You haven't been born yet. Now, if I run this code, I'll say that my age is -1. This condition is false. We skip this code. This condition is true. Therefore, we will execute this code. And we skip the else statement. You haven't been born yet. Let's add another else if statement. You can add as many else if statements as you want. Let's check to see if somebody's age is greater than or equal to 100. We'll print a different message. Let's print, you are too old to sign up. If I were to say my age is 111 years old, well, it states you are now signed up. The reason that we didn't reach this part of our else if statement, that's because this condition is still technically true. You do need to pay attention to your order of if and else if statements. If I want to be sure that nobody over 100 is signing up, I should probably move this to the beginning. If age is greater than or equal to 100, then else if age is greater than or equal to 18, we'll do something else. Enter your age, I am 111 years old. You are too old to sign up. So those are if statements. If some condition is true, do something. Else if, you can check something else. If no above conditions are true, you could do something else entirely. It's kind of like the default. Here's another example. We'll ask a user if they would like some food. Response equals input. Would you like food? We'll have the user type in Y for yes or N for no. If our response, now to check to see if two values are equal, you would use double equals. If the response is equal to Y, then we will print have some food. The doubles equal sign is the comparison operator. It will check to see if two values are equal. You don't want one equals because that's the assignment operator. Python, in this case, thinks we're attempting to assign the character Y to response. So for comparisons, use double equals. Else, we can print no food for you. So, would you like food? I'll type Y, have some food. Let's try it again. I'll type no, N for no. No food for you. Here's a third example. We'll have a user type in their name. Name equals input. Enter your name. If our name is equal to an empty string, that means they didn't type in anything. So let's yell at the user. You did not type in your name. Else, we will print, using an F string, hello, whatever the name is. Enter your name. I'm just going to hit enter. You did not type in your name. Let's run this again. I'll type in my name. And we have executed the else statement this time. Hello, bro. So one important thing that you should know is the use of Booleans with if statements. Suppose we have some Boolean variable named for sale. I'll set this to be true. Now, using an if statement, you can just use the Boolean variable in place of a condition, because a condition would evaluate to be true or false. We could just say, if for sale, if that's true, then let's print this item is for sale. Else, we will print this item is not for sale. For sale is set to be true. This item is for sale. If this variable were false, well then the item is not for sale. Let's try a different variable. How about online? If online, the user is online. Else, the user is offline. So, the user is offline. I'll change the Boolean to true. The user is online. So with if statements, you can either write a condition, or you could use a Boolean. Alright everybody, so those are if statements. Do some code only if some condition is true. Else, you can do something else. It's a basic form of decision making, and those are if statements in Python. Hey everybody, this is a remake of my Python calculator program for absolute beginners. All you need to know to complete this exercise is just if statements and how they work. So let's get started. For this exercise, a user is going to select an arithmetic operator. Operator equals input. We will ask the user to enter an operator. This will be plus for addition, minus for subtraction, asterisk for multiplication, and a forward slash for division. You could enter more than this, but I don't want to make this exercise too complicated. We will create a variable of num1 to contain our first number. Let's say we would like to add two numbers together. What is the first number going to be? Enter the first number. And let's do this with the second number. Num2. Enter the second number. Let me show you something. I'm going to add num1 and num2 together. Num1 plus num2. We'll do a test run. Enter an operator. I would like to use addition. Enter the first number. 10 and 11. Well, the result is 1011. When we accept user input, they are string data types. What we've ended up doing is string concatenation. We've concatenated the string of 11 to 10. That's why we ended up with 1011. We'll have to convert these two strings to be floating point numbers by typecasting them as a float. So enclose your input functions with a typecast of float. And now we should be able to add those two numbers together. So let's add 10 and 11. And we get 21.0. Depending on the operator that the user selects, we'll use some if statements to determine that. We will check if our operator variable is equal to a character of plus. And for now, I'll write pass as a placeholder. We'll get back to this later. Else if our operator is equal to minus, we will use subtraction. And for now, I'll write pass. Else if operator is equal to an asterisk for multiplication, we will multiply. Else if our operator is equal to a forward slash for division, we will divide. If our operator is addition, let's create a variable of result. Result equals num1 plus num2. For subtraction, it's going to be num1 minus num2. Multiplication would be num1 times num2. Then division would be num1 divided by num2. Then we just have to print the result. Print our result. Be sure to do this with each of the else if statements as well. And let's see what we have. Let's add 5.5 plus 6.9. That gives us 12.4. Let's subtract 420 minus 0.69. That gives us 419.31. Let's test multiplication. Multiply 3.14 times 3.14, which gives us 9.8596. Then division. Let's divide 69 by 13. And that gives us a really long number. So you could round a number if you would like. We would enclose our result within the round function. And we'll just update each of these print statements. This will round to the nearest whole integer. So let's divide 420 by 13. Let's say that we would like 3 digits after the decimal. Within the round function, we could add comma 3 for 3 decimal places. Enter an operator. Let's use division. Divide 420 by 69. So that gives me 6.087. So we can round to a given digit after a decimal. In this case, 3 places. What if somebody types in an operator that doesn't exist, like the word pizza? Then I will divide 2 numbers. Well, let's add an else statement. If somebody selects some input that is invalid, let's let them know. I'll use an f string. Let's say that the operator that the user has selected is not valid. And let's try this again. Enter an operator, pizza. Enter the first number, 420 and 69. Pizza is not valid. Let's say is not a valid operator instead. That makes more sense. Pizza will be my operator. First number is 420, second number is 69. Pizza is not a valid operator. All right, everybody, so that is a very simple Python calculator program you can make as a beginner. Hey there, it's me again. In today's topic, we're going to create a weight converter program in Python. This is an exercise that will follow up the lesson on if statements. We'll convert pounds to kilograms or kilograms to pounds. The user is going to decide. We will begin by creating a weight variable. We will assign some user input. Enter your weight. We will convert this input into a floating point number. So add that cast. Then we will ask for a unit. Is this weight in kilograms or pounds? Input, kilograms, or pounds. We want the user to type in either K for kilograms or L for pounds. And these are capital letters, by the way. Using an if statement, let's first check to see if our unit is equal to a capital K. That means the current weight is in kilograms. We need to convert that weight to pounds. Let's reassign weight equal to our weight times 2.205. Else if unit is equal to L, we need to convert to kilograms. Weight equals weight divided by 2.205. Else the user did not type in something that was valid. Let's print, using an f string, unit was not valid. At the end of our program, we will print the new weight. I'll use an f string. Your weight is our new weight after it's reassigned. Now we need a unit of measurement. This is what I'm thinking we'll do. Within our if and else if statements, let's reassign our unit. We're reassigning unit to be LBS for pounds. Else if unit equals KGS for kilograms. In our results, we will display our new unit. Let's take a look. Enter your weight. Actually, I'm just going to make one change. I'm going to add colon space. There, that's much better. Enter your weight. Let's say I'm 180 pounds. This is in pounds. I'll type capital L. Your weight in kilograms is 81.63. I think I'm going to round this. I will enclose the weight variable within a round function. We will round to 1 decimal place. Let's try this again. Enter your weight. Maybe I'm 81 kilograms. I'll type K for kilograms. Your weight is 178.6 pounds. Let's make sure that this else statement works too. Enter your weight. 180 pizzas. Pizzas was not valid. So we're still displaying our output. We would want to avoid that if somebody doesn't type in a valid unit. So let's cut this line, then paste each within the if and else if statements. When we exit the else statement, we're not printing the output. So let's make sure that this works. Enter your weight. I am 180 pizzas. Pizza was not valid. All right, everybody. Well, that is a weight converter program in Python. I thought this would be a helpful exercise now that we have finished the section on if statements. And yeah, that is a weight converter program in Python. Hey everybody, in this topic, we're going to create a temperature conversion program as an exercise. We'll begin by asking what the current unit of measurement is. Unit equals, we'll accept some user input, is this temperature in Celsius or Fahrenheit? C/F. Then we will ask for the temperature. I'll store the temperature in a variable named temp, meaning temperature. Temp equals input, enter the temperature. Then we should cast our user input as a floating point number. If unit is equal to C, I'll fill this in momentarily. I'm just going to write pass as a placeholder. Else if unit is equal to F, we will do something else. Else, let's print something, just an error message of some sort. Using an F string, unit is an invalid unit of measurement. Let's test this else statement. Is the temperature in Celsius or Fahrenheit? What if I were to type K for Kelvin? I'll make up some temperature like 100. K is an invalid unit of measurement. All right, we know the else statement works. Let's convert Fahrenheit to Celsius using this formula. We will take our temperature equals 9 times our temp divided by 5 plus 32. I'll take all of this and use the round function. We'll round to 1 decimal place. Then we will print the current temperature in Fahrenheit. I'll use an F string. The temperature in Fahrenheit is our temp variable, degrees Fahrenheit. Let's test this if statement. Is the temperature in Celsius or Fahrenheit? It is currently in Celsius. What is 33 degrees in Celsius converted to Fahrenheit? The temperature in Fahrenheit is 91.4 degrees. All right, so this section is working. Let's work on the else statement. Else, if our unit is currently in Fahrenheit, we'll convert to Celsius. That formula is temp equals our temperature minus 32 times 5 divided by 9. Then I will round the result to 1 decimal place. Then we'll print the temperature in Celsius. The temperature in Celsius is temp degrees C for Celsius. Is the temperature in Celsius or Fahrenheit? It is currently in Fahrenheit. Enter the temperature, 91.4. The temperature in Celsius is 33.0 degrees Celsius. Well, everybody, that is a simple temperature conversion program in Python. All right, people, we're talking about logical operators today. Logical operators allow us to evaluate multiple conditions. We can link them together. There's 3 we'll discuss: or, and, not. We'll begin with or. With or, we can check more than one condition. If at least one of those conditions is true, then the entire statement is true. Here's an example. Let's say we have an outdoor event, and I will create 2 variables. One, temp, meaning temperature. Let's say that this is in Celsius, 25 degrees Celsius. Pick Fahrenheit if you would like. And I will create a Boolean variable of is raining. I will set that to be false. It is currently not raining. If the temperature is too hot, too cold, or it's raining, then I will cancel this outdoor event. We'll write an if statement to check that. If our temp short for temperature, is greater than, let's say, 35 degrees Celsius. Then I'll use the OR logical operator, or if our temp is less than 0, or if is raining is true. If one of these conditions is true, we're going to cancel our outdoor event. So let's print the following. The outdoor event is canceled. Else, we will print something else. The outdoor event is still scheduled. The temperature is reasonable, and is raining is false. It's not raining. So we print the else clause. The outdoor event is still scheduled. What if the temperature was really hot, like 36 degrees Celsius? Well, the outdoor event is canceled. What if it's cold? -5 degrees Celsius. The outdoor event is canceled. This condition was true. Therefore, we execute the if statement. Or what if the temperature is reasonable, but it's raining? Is raining is true. Well, then the outdoor event is still canceled. So with the OR logical operator, at least one of these conditions needs to be true. If one of these conditions is true, you could consider the entire statement true. Now let's cover AND. With AND, we can link two conditions together. Both conditions must be true in order for that entire statement to be true. So again, let's say we have temp short for temperature, and we have a Boolean variable of is sunny. I will set that to be true. We will check if our temp is greater than or equal to 28 degrees Celsius. And is it sunny? Is sunny. If it's hot, and if it's sunny, if this is true, let's print the following. It is hot outside. For fun, I'm going to add an emoji, but you don't have to. I just think it's more entertaining that way. But you do you. And I will print, it is sunny. Sometimes these emojis are formatted differently. I'm just going to copy it from somewhere else. That's better. Currently, the temperature is 25 degrees Celsius, and it's sunny. This condition was false, but this one is true. With the AND logical operator, both conditions must be true in order for us to execute this block of code. If our temperature was 30 degrees Celsius, well then, both conditions are true. It is hot outside, and it is sunny. Let's write a few more. Let's add else if. Else if the temp is less than or equal to 0 and is sunny, we will print something else. It is cold outside. I'll change the emoji. And it is sunny. Let's set the temperature to be -5 degrees Celsius. It is cold outside, and it is sunny. Both these conditions are true, so we do this instead. You can link as many conditions together as you would like. Let's see if our temperature is within a certain range. Else if temp is less than 28, and our temp is greater than 0, and is sunny. To check to see if something is within a certain range, there is a shortcut too. PyCharm is recommending this. We can simplify chained comparisons. So this effectively does the same thing. If 28 is greater than our temp, and our temp is greater than 0, and it's sunny, then we will print it is warm outside rather than hot. And it's still sunny. So let's say our temperature is 20 degrees Celsius, and it's sunny. It is warm outside, and it is sunny. Now we have the not logical operator. It inverts the condition. We are checking to see if something is either not false or not true. So let's check to see if it's not sunny. Really, I'll just copy what we have and paste it. Else if not is sunny, then that means it's cloudy. And let's use a cloud emoji. So basically, not does the opposite of what you're looking for. We are checking if not is sunny. Is sunny is false, then this condition is true. Okay, let's say our temp is 28. Is sunny is now false. It is hot outside. It is cloudy. What if our temperature was 0? It is cold outside. It is cloudy. What if the temperature was reasonable, like 20 degrees Celsius? It is warm outside. It is cloudy. So not, it inverts the condition. If it's true, it's now false. If it's false, it's now true. Alright everybody, so those are logical operators. They allow us to evaluate multiple conditions. With or, at least one condition must be true. With and, both conditions must be true. And not does the opposite. It inverts the condition. We check if something is not false or not true. And well everybody, those are logical operators in Python. Hey everybody, so today I gotta explain conditional expressions in Python. A conditional expression is a one-line shortcut for using an if-else statement. If you're familiar with other programming languages, this is also known as the ternary operator. It behaves similarly. Using conditional expressions, we can print or assign one of two values based on a condition. Here's the formula. Return x if our condition is true, else return y. Here's a basic example. We will create a variable for a number, just num. Let's say our number is 5. I'm going to print, then within our print statement, I will write a conditional expression following this formula. I'll just copy and paste it. Let's check to see if our number is positive. Let's print the text positive if our condition. What are we checking? Let's check to see if num is greater than 0. That means it's positive. If this condition is false, we will instead print whatever comes after else. Else, negative. Number is 5, that will print positive. If our number was negative 5, well, this condition would be false. We would instead print negative. Let's go over another. Let's check to see if our number is even or odd. Let's set num to be 6. This time I will assign the result to a variable. Our result equals, take our formula, let's assign even if our num modulus 2. Is our number divisible by 2? Does that equal 0? Else return odd. Then let's print our result. Result. Number is 6, that is even. If it's 5, then it's odd. Assign even if our number is divisible by 2, else return odd. Let's create variables a and b. A will equal 6, b will equal 7. Let's create a variable of max num equals, follow our formula again, return variable a if a is greater than b, else return b. Between a and b, which is the maximum number? That would be b of 7. Let's find the minimum this time. Min num a if a is less than b, else return b. The minimum number between 6 and 7 is 6. This time we'll take an age. Age equals 25. We will create a variable of status equals, use our formula again, return a string of adult if our age is greater than or equal to 18. Else return a string of child. Then we will print our status. Our age is 25, that's greater than or equal to 18, we will print adult. If our age was 13, then we are a child. We will instead return child. Let's work with the temperature. Temperature equals 30 degrees Celsius. So that's hot. Let's create a variable of weather. Assign a string of hot if our temperature is greater than 20. Else we will return a string of cold. What's the weather outside today based on the temperature? It is hot. If our temperature was 20, then the weather is cold. Okay, last example. We will work with a user role. I will set this to be admin. We will define a variable of access level equals, again, follow our formula, return the text of full access if our condition of user role is equal to a string of admin. Else we will return limited access. Our user role is an admin. Let's print our access level, and we have full access. But what if we were a guest? Well, then we have limited access. All right, everybody, those are conditional expressions. They're a one-line shortcut for the if-else statement. It's similar to the ternary operator in other programming languages. Using conditional expressions, we can print or assign one of two values based on a condition. You follow the formula of return X if our condition is true, else return Y if it's false. And well, everybody, those are a few examples of conditional expressions in Python. Hey everybody, in this topic, I'm going to cover a few useful string methods that you may be interested in. Then at the end of this video, we will work on an exercise where we will validate some user input. As we know, a string is just a series of characters. Let's ask a user for their full name. Name equals input. Enter your full name. The first method I'll show you, well, technically this is a function. The length function will give us the length of a string. How many characters is it? We will find the length of our variable name after the user types in some input. This function returns an integer. I'll store that result within a variable, let's just say result. Then I will print whatever the result is. Why don't you go ahead and type in your full name? The length of this string, in my example, is 8 characters. That does include spaces too. 1, 2, 3, 4, 5, 6, 7, 8. If you ever need the length of a string, there is the length function. Let's move on. If we were to type our variable, name, followed by a dot, we have access to a whole bunch of different methods. We have the find method. The find method will return the first occurrence of a given character, the position. Let's find any spaces. I'll store the result within a variable named result. I will type in my full name. The first occurrence of a space, that's what we set, is at position 3. When working with indexes, we always begin with 0. This first character would have an index of 0, then 1, 2, 3. That's why the find method returned 3 in place of 4. Let's find the first occurrence of a capital B. See, it's 0. How about O? For me, that would be 2. So remember, it's always the first occurrence. If you need the last occurrence, there is a different method, which is rFind. R meaning reverse. We will find the last occurrence of an O. That has a position of 5. 0, 1, 2, 3, 4, 5. If Python isn't able to locate a given character, it will return -1. Let's find any, I don't know, Q's. Python could not find any lowercase q's, the rfind method will return -1 if there are no results. We can capitalize the first letter in a string by using the capitalize function. Name dot capitalize. This method will return a string. I will reassign that to name. Then we will print our name capitalized. I'll be sure to type in my name, all lowercase. Since this is all one string, only the first letter is capitalized, even though I'm including a first and last name. The upper method will take all of the characters in a string, then make them all uppercase. Follow your variable that contains a string, followed by .upper. Then I will reassign the result to my name variable to overwrite it. Enter your full name. All of the letters are now uppercase. There is also lower to make all of the characters lowercase. Name equals name dot lower. Yep, all the characters are lowercase now. The isDigit method will return either true or false if a string contains only digits. The result is a Boolean, true or false. I'll store that within a variable named result, then print result. So if I were to type in my full name, isDigit returns false. There are not only digits within that string. If my string was some combination of alphabetical characters and numbers, this method will still return false. It only returns true if my string only contains digits. I'll just type in 1, 2, 3. See, that's true. That is the isDigit method. Otherwise, we have isAlpha. Name.isAlpha. The isAlpha method will return a Boolean true or false, depending if a string contains only alphabetical characters. I'll type in my full name. So the reason that this came up false is because my full name contains a space, which is not an alphabetical character. If I typed in my full name, excluding any spaces, this would now be true. isAlpha would also return false if my name contained any sort of digits, bro 1, 2, 3, and that is also false. That is the isAlpha method. Now let's ask for a phone number. Phone number equals input. Enter your phone number. With the phone number, they typically contain dashes. Let's count how many dashes are going to be in somebody's phone number. Phone number dot count method. Let's count the amount of dashes. So place a character within the count method. This method will return an integer. Let's store that within a variable. Result equals phone number dot count method. So type in some phone number, 1-234-567-8901. We have 3 dashes within the string. 1, 2, 3. That is the count method. We can count how many characters are within a string. We also have the replace method. Honestly, the replace method is probably one of the most useful methods of strings. We can replace any occurrence with one character with another. Replace. Let's replace any dashes with maybe a space. This method will return a new string. I'm going to reassign this to our phone number variable. Then print the phone number. Enter your phone number, 1-234-567-8901. So here's my new phone number, but we've replaced all of the dashes with spaces. Even better yet, we could eliminate all the dashes completely by replacing the dashes or another character with an empty string. 1-234-567-8901. Here's our new phone number without any dashes. We've replaced all dashes with an empty string, no characters. If you would like a comprehensive list of all of the string methods available to you, you can use the help function, type in the data type str, meaning string, then I will print whatever the result is. here's a bunch of methods you might be interested in the future. Capitalize, casefold, center, count, encode, ends with, just to name a few. All right, everybody, here's an exercise for you. We will validate some user input. We would like a user to enter in a valid username. However, there's a couple of rules. The username can be no more than 12 characters long. The username must not contain any spaces, and the username must not contain any digits. Let's assign a variable named username equals input. Enter a user name. First, let's check to see if our user input is more than 12 characters long. We can do that using the length function. We will find the length of our username. The length function returns an integer. Let's check to see if the length of our username is greater than 12 characters. If it is, we'll print a message. Your username can't be more than 12 characters. Else, we will print, using an F string, welcome whatever our username variable is. Let's try it. I'll type in my first name, last name, then add a whole bunch of characters afterwards. Your username can't be more than 12 characters. Let's type in something that's under 12 characters. Yep, and that appears to work. Okay, so we have accomplished task number 1. Our username can't be more than 12 characters. Next, our username must not contain any spaces. We can use the find method of a string. Username.find. We will find any spaces. That's a character. If no spaces are found, this method will return -1. Using an else if statement, I'll add not. If the find method of username equals -1. If the result is not -1, meaning we found a space, we will print your username can't contain spaces. I'll type in my first and last name. You might need to think of something that's underneath 12 characters. Your username can't contain spaces, so we have accomplished rule number 2. 3, username must not contain digits. We can use the isAlpha method of strings. The isAlpha method returns a Boolean if a string only contains alphabetical characters. So let's copy that. I'll add another else if statement. Not username is alpha. Then we will print your username can't contain numbers. I guess technically isAlpha would check for spaces too, but I'd rather have that be handled within a different if statement. All right, I'll type in a username. I'll include some digits. Your username can't contain numbers. All right, I think we've accomplished this. Let me make up a username following these 3 rules. Yep, it seems to check out. All right, everybody, and that is a few useful string methods that you may be interested in. Hey everybody, in this topic I'm going to explain string indexing. Indexing allows us to access the elements of a sequence using a set of square brackets, also known as the indexing operator. Using this set of square brackets, following a string, there are up to 3 fields that we can fill in. We can access a starting point in the string, an ending point, and a step. Here's an example. Suppose we have a credit card number. Credit number equals, and I'll just make up some number, 1234-5678-9012-3456. Good enough. If I need the first character within the string, I can type the name of my string variable, followed by the indexing operator, which is a set of square brackets. The first position has an index of 0. Computers always start with 0, so that's why the first index is 0. Then I'm going to go ahead and print this. Print credit card number at index of 0. That would be 1. If I were to change the index to be 1, 0, 1, that should be 2. Index 2 would technically be 3. Then 4 is the dash within our string, as you can see here. With the indexing operator, there's up to 3 fields that we can fill in: a start, end, and step. If you have just one field listed without any colons, it's assumed you're filling in the starting position. So now what if you would like the first 4 digits of the string? Well, we would type the name of our string variable, indexing operator. We'll need a starting index, colon, then an ending index. The first 4 digits would be 0, colon, 4. Then I will print this. And I'm just going to turn this first line into a comment. Yeah, there we go. We have the first 4 digits of our credit card number. 1, 2, 3, 4. Just so you know, with the ending index, this index is exclusive. This first number would be 0, 1, 2, 3, 4. So we did not include that dash within the number. The starting index is inclusive. The ending index is exclusive. So you can omit the 0 in the beginning. You could just say colon 4. Python assumes the starting position will be the beginning of the string. So that would work too. Let's get the next set of digits, 5, 6, 7, 8. Credit number, indexing operator. Let's find where the starting index would be. 0, 1, 2, 3, 4, 5. 5, colon, 6, 7, 8, 9. Then we will print whatever is here. The next set of digits is 5, 6, 7, 8. Maybe we need the last 12 digits. Well, what we could do in that case, we will take our string variable, credit number, set the starting index to be, let's see, 0, 1, 2, 3, 4, 5. 5, colon. If you need everything up to the end of the string, you don't need to list an ending index, just be sure to add that colon. Python then assumes you need everything up to the end of the string. So I will print whatever we have. Then we should have everything besides the first 4 digits. Yep, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. You could also use a negative index. Credit number. If you need the last character in a string, you would set the index to be -1. Then I will print this. Print credit number at index of -1. That would be 6. -2 is 5. -3 is 4. -4 is 3. And then -5 would be that dash right here. Yeah, you can use negative indexes too. Let's talk about step. Using the step field, we can access the characters in a string by a given step. We can count by 2s, or we can count by 3s. So here's an example. So let's take our credit number. If we're not filling in the starting or ending fields, but we need a step, we would need 2 colons then. Python is assuming everything from the beginning of the string to the end then. Our step will be 2. This will print every second character within our string. Yeah, here we are. We have 1, 3, dash, 6, 8, 9, 1, so on and so forth. If I were to change the step to 3, we would count every third character, beginning with 1, 4, 6, dash, 1, 3, 6. All right, here's a practical example. Let's create a program to get the last 4 digits of a credit card number. I'm going to assign this to a new variable. Last digits equals our credit number, indexing operator. So we need the last 4 digits. Where would the starting index begin? Well, we could use negative indexing. This last digit is -1, -2, -3, -4. We will begin at -4. Colon. We can omit the ending index. Python assumes we need the rest of the string then. Really, that's all we need. So let's print. I'll use an F string. Maybe some X's. Maybe we're hiding somebody's credit card number except the last 4 digits. Okay, then variable last digits. All right, and here's our credit card number where only the last 4 digits are visible. Hey, you know what? Let's add one more exercise. Let's reverse the characters in the string. I'm going to reassign credit number equals credit number. If we need the entire string, we don't necessarily need a starting index or an ending index. But for the step, this will be negative. -1 will reverse a string. Then let's print whatever our new credit card number is. Print credit number. And yeah, there is our credit number backwards. To reverse a string, you set the step to be -1. So yeah, everybody, that is string indexing in Python. We can access elements of a sequence using the indexing operator, which is a set of straight brackets. You can list a starting position, ending position, and even a step if you need to skip over characters. But yeah, that is string indexing in Python. Hey everybody, in this topic I'm going to explain format specifiers. Format specifiers, when used in the context of an F string, they allow us to format a value based on what flags are inserted. Following your value, you would type a colon and then some flags. Depending on what flags you insert, it will format your output a certain way. You could add decimal point precision, allocate space, 0 pad values, left justify, right justify, center align, all sorts of things. Let's have some practice. I'll create 3 prices. Price 1, price 2, price 3. Price 1 will be 3.14159. These values aren't in dollars and cents yet, but they will be. Price 2 will be -987.65. As you can see, I'm just making up numbers here. Price 3 is 12.34. Let's display our prices using some F strings. Price 1 is placeholder price 1. Then we will do this for price 2 and price 3. Price 2 is price 2. Price 3 is price 3. Within our placeholder, following the value, we can add a colon, then some flags. Those flags are the format specifiers. They will format our value a particular way depending on what we insert after the colon. To add decimal point precision, you would type, after the colon, dot, then the amount of decimals to be displayed, maybe 2, then F meaning floating point number. Let's do that with price 2 and price 3. Colon, dot, to F. Price 1 is now 3.14. Price 2 is -987.65. Price 3 is 12.34. I think I'm going to add some dollar signs before the placeholder. Yeah, that's much better. For less precision, maybe 1 decimal place, you can change the 2 to a 1. So 0.1F. Each number only displays 1 decimal. 0.1, 0.6, 0.3. Whereas in 0.3F would display 3 decimal places. 0.142, 0.650, 0.340. Even though price 2 and price 3 only have 2 decimal places in the original numbers, we will concatenate some additional zeros. To allocate space to display a value, after the colon, add some number for that many spaces. How about 10? Each value now has a total of 10 spaces to display the output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you were to precede a number with 0, well, these numbers would be 0 padded. Each number is now 0 padded. To left justify a value, you would use a left angle bracket. all these numbers are now left justified. Then we have all of the space after. They're all uniform. Right justify would be a right angle bracket. And I believe that's the default. Center align, I believe, is the caret symbol. Yep, our numbers are now centered. If you have any positive values, and you would like to display a plus sign, just use plus. Any positive number is preceded with the plus sign, any negative number is preceded with the negative sign. Or you could use a space for any positive numbers. So colon, space. These numbers are lined up evenly, even though we have a negative number in here. There is a thousandths separator, which is a comma. We should probably increase the value of our prices. 3,000, negative 9,870, 1,200. Each thousandths place is now separated with a comma. We could also mix and match flags. I would like a thousandths separator along with decimal point precision of 2 decimal places. And why not? I will precede each number with a plus sign if it's positive. Yep, here we are. So based on what you're looking for, you can add some combination of flags. So yeah, those are format specifiers, everybody. Within your placeholder, insert your value, a colon, then certain flags based on what you're looking for exactly. But yeah, those are just a few format specifiers in Python. Hey everybody, in this topic I'm going to explain while loops. A while loop will execute some code while some condition remains true. Here's an example. We'll use an if statement first. We will ask a user for their name. Name equals input. Enter your name. If our name is equal to an empty string, that means the user didn't type in anything. Let's print a message. You did not enter your name. Else, we will print, using an F string, hello, our user's name. If I were to skip this prompt, we would execute this if statement, then we continue with the rest of the program. What if I would like to continually prompt the user to type in their name? We can't continue until they type in something. Well, we could replace this if statement with a while loop. While this condition is true, continue to execute this code. Within the while loop, I'm going to reprompt the user to type in a name. Then if we were to exit the while loop, then we will print hello, whatever your name is. So let's run this. Enter your name. I'm going to hit enter. You did not enter your name. Enter your name. No, no, no. Okay, I give up. I'll type in my first name, hit enter. Hello, whatever your first name is. While this condition remains true, execute this code potentially forever until this condition is no longer true. So that's one of the main benefits of a while loop. If it's not true, then you exit out of the while loop. And that's why we're able to continue, then print our name. Hello, name. You do want some way to escape out of the while loop, otherwise you'll run into what's known as an infinite loop. So let's say while name is equal to an empty string, we will print, you did not enter your name. So I'm going to hit enter. So we are stuck in an infinite loop. We can't actually escape this loop. We didn't give ourselves an exit strategy. That's why previously we reprompted the user to type in something. We're giving them a chance to escape. In a way, it kind of works like an if statement, but instead of executing some code once, it's potentially infinite. Here's another example. This time, let's ask for a user's age. Age equals, and I will convert the input to an integer. Enter your age. We'll need the user to type in a positive number. While age is less than 0, let's print a message to let the user know that they can't do that. Age can't be negative. Then we need some strategy to escape. let's reprompt the user to enter in their age. Once they type in something that's valid, we can escape out of the while loop. So let's print, using an F string, you are age years old. So enter your age. I'm going to say -1. Age can't be negative. -2. -1 million. Okay, I give up. How about 21? You are 21 years old. So that was another example. While our age variable is less than 0, repeat this code forever. Let's go over example 3. I'm going to introduce some logical operators. We will have the user type in a food they like. Food equals input, enter a food you like. But in order to escape, they need to press Q to quit. While food is equal to the letter Q, continue this while loop. However, I'm going to make